This is the PhET Wave Interference Simulator, and if you choose the Waves tab to start, this is what you see. It defaults to having a water wave set up, and so this is like a little faucet that I can turn on and drip drops of water into this. But we want to for our purposes. Look at lights over here, and I've got sound and light. And light is a little light source here. If I turn this on, it represents light as a whole series of waves, and in fact, if I turn it to the side view, I get the exact same picture as I do in the top view. And that's intended to represent that this is actually a three-dimensional effect, even though it's being obviously represented on a computer screen two-dimensionally. So we're back to the wave representation of light here, and we're asked what if anything changes if you change the frequency of the light waves, and what about the amplitude? So if I change the frequency, it starts out in green, but if I go to the red, you'll notice that here the wavelength is longer, so you see a bit more distance between those red peaks of the waves that are traveling outward. And if I go up to the blue-violet end of the spectrum, it is in fact a shorter wavelength, so there's less distance between those. I believe if you change the amplitude, it's simply going to change the color intensity, the brightness that is representing there, so that's the maximum amplitude the simulation allows, and we can turn it down near the minimum, and so they are representing dimmer light by. Well, dimmer light on the screen less bright colors there as it's moving out, and you can represent a couple of things on here. You can show a graph, so this graph is basically showing the oscillations of the electric fields that we've seen in other representations, and a couple of lectures down the center of the simulation. So that's what the graph shows you.